In figure 8.1, we have a really good diagram of how we think about clays. This whole chapter 8, is concerned with what they call colloids, which are just particles, very small particles that are in the soil. So you can think about a broken down rock, for instance, and having that broken down into particles such as sand, silt, and clay. Once we get to the clay size of particle, we actually have really, really small particles that have really interesting features. And what you're seeing in this figure is part of those features. You can see that in the soil solution, okay, the water that's surrounding the soil, we have a lot of ions, what are called ions, floating around in that soil solution. Ions are just either positively or negatively charged elements. Okay, so we have aluminum and potassium and hydrogen and calcium and magnesium floating around in there. We also have we have positively charged ones. We have negatively charged ones. Here's nitrate. This is a form of nitrogen that's taken up by plants. That's floating around in there as well. Well, it turns out that our clays, so these layers here, as you can see, this, and we've seen this before to some extent, this clay particle is composed of layers. We'll discover what's in those layers later on in this chapter. But these particles are actually negatively charged. So there is a negative charge to these particles just within them. You can think about this charge being inside the particle and how it's composed. So it can actually attract positively charged ions onto its negative charge inside the particle, and this is what we will call cations. So these are cations, these positively charged particles, ions. These are called cations. So we call this cation exchange capacity, because these clays are actually able to exchange different cations. You'll learn about that in a little while. But this is a really good example of what's actually happening in the soil, and many of these cations are plant nutrients. And so these are good to have on the soil, and there's a relationship, there's an equilibrium between what's on the soil and what's out here in the solution, so that if a plant might take away these three potassiums and this magnesium and this calcium out, okay, so let's take those all out into this plant root that's growing, those nutrients can be replaced because there's an equilibrium between what's in and on these sites and what's outside in the solution. So some of these potassiums might go out into the solution, and magnesium might go out. Actually, these are more typical. The ones on the edge are more typical to go out into the solution. So that's a sort of relationship that we find in clay, and this is typical of a soil colloid. So again, a colloid is just another name for most typically either a clay or organic matter. We can have some other things, iron oxides and some other things that also act like colloids. You're familiar with colloid because unless you're lactose intolerant, but you're familiar with it, and that is milk. Milk is actually a suspension, so it's actually like a liquid with proteins and fats and things suspended up in it. They're not completely dissolved into milk. We do a good job of homogenization so that we blend everything up, but if we had raw milk out of a cow, it would sit and the cream would rise to the top. So there's actually particles of fats and things that are in the milk that when we mix it all up, it acts like just a plain old solution, or suspension, and we can drink it, and we don't think about it being a suspension. But if you were to look with a microscope at a droplet of milk, you'd see, a really good microscope, you'd see that it's made up of little tiny particles of fats and things like that. That's in that milk we consider a colloid, a really small thing that's suspended in a solution, and the same thing happens here, only our colloids are way more awesome, I would like to say. Because they do they have this negative charge to them, and they do some interesting things with that. We'll discover that later on in this chapter.